But where the weight is, it's complicated by a pulley. So I'm going to start where the tension is. If a T is pulling, if the load is pulling the rope is T, that means that this load right here in that cable is T. And if that cable is going around pulley A, and it's a standard pulley that I passed around, the one that spins, that means what load is going on the cable on the other side of A?
T.
Still T. I'm not talking about negative and positive, because it all depends on which way I'm pulling, right? Okay, so we're not dealing with negative and positive. This is T, this is T. Now the same cable, it's still a continuous cable, goes around pulley B, and it's up here. So what load is in this cable? T. Right? So it's all the same cable. So if I am here pulling a load of T, this whole cable is experiencing T because we're ignoring all the friction that could be in the pulley. Okay, now you're comfortable with drawing free body diagrams. I'm going to draw a free body diagram of pulley B. What's happening at pulley B? Well, I see that there's a tension going up here, and there's a tension going up here, and there's another tension going down. Because we're dealing with statics and it's not moving, we could apply some of the forces equal to 0. And in this case, we're looking at forces on the y-axis. What is the pull going down for it to be in equilibrium?
2T.
2T. Questions so far? So I'm going to write that then. If I just learn that this is 2T, that means this cable right here has a tension of 2T. So if this cable is 2T, what is the force going through this cable here? 2T. So then I could draw, can I draw a free body diagram now of pulley C? I have 2T going up, I have 2T going up, and I have a tension coming down. What is that tension coming down? 4T. So right here, there's 4T. So then I could draw a free body diagram of this link. I have a weight going down, and I have 4T going up. What is weight equal to? 4T. So just to review, I'm pulling a load of T through this cable. So that means this cable is experiencing T here, T here, T here. Why? Why is it all T? It's one cable. It's a continuous cable. So that means when I do the free body diagram of B, I have a T going up, a T going up. So this one must be 2T. And I'm drawing it down because it's going away from my free body diagram. Tension always goes away from a free body diagram. If Rachel pulls my arm, she's pulling my arm in tension, and this is the body we're analyzing, tension is being pulled away from the body you're analyzing. So when I look at pulley B, all the tension is drawn away because it's pulling. It's a pulling force. Then when I go, if this is 2T, then I know, since this is a continuous cable, this guy right here is 2T. So when I draw my free body diagram for pulley C, I have 2T going away, 2T going away. This has got to be 4T because, again, sum of the forces in the y equals 0. And therefore, when I draw a free body diagram of my link, I have 4T is equal to W. Questions? Yeah, Santiago.
Sam and I found it easier to go backwards to start at the weight.
You could do that if you want. So if we went backwards, I'll grab another color. The only thing is we'll have to figure out what we'll call it something different. So, let me just take a new one. So this is W, right? That means that this has got to be W right in here. And when I do a free body diagram of C, I have W going down, and I have two things going up, so this, what is this gotta be? Oh, yes, thank you. So if I have, this is W, I have W drawn down on pulley C, and I have two things drawn up, what are these guys gonna be? W over 2. So that means this is W over 2, this is W over 2. So now when I do B, I have W over 2 going this way. So what do I have going up? W over 4, W over 4. So that means this is W over 4, this is W over 4, this is W over 4. And then that means here, T must be equal to W over 4, so W is equal to 4T. So either way works. Okay. Okay, let's do the next one. Now you're going to be doing it with yourself. So right here, what do we have? We have a P and we have a W. Or you could start up here. Could I do this? You guys mind? I'm going to put a T on here. You could call things whatever you want. Do not start at this W. Because notice there's a link that's connecting to another wire, right? So we have to figure that out. So start from the left. Sam?
So with those ones, is the wire connected to the pulley itself?
Which one?
Is W connected to the pulley directly?
At point A, we have a W going down and we have 3 cables going up.
So, but is that metal bar attached to the pulley?
Yeah, it is. Yeah, it's, oh yeah, it's not free. And the way you know that is if you look close, you see the little circle, which means there's a pin here. A pin is like what's on a pinwheel. So you could spin it, you know, one of those pinwheels. So in this problem, you're finding the relationship of P and W.
So then this one right here
You could add T in there,
in the middle.
but in the end, they're going to want to find out. I mean, if the problem is, it depends on
So
what the
then this
problem
has to be
is.
3
But
P.
find the relationship of T with W and P with W.
So then this has to be 9.
Did you need an answer? No. Do you need an answer?
No, I yeah, I have to look at it.
So this is 2T. Well, I guess this has to be 2T. Yeah. So then 2T.
Kyle, I need your signature on this.
But what about this guy? This would have been 4. Where's 4?
Checked you off of the agenda.
Yeah, I put 4 up there. That, yeah, that's what I was saying. But then, so then the weight has to be 4. Or this is 4? No, because this is T. Yeah, so that's weight.
You can move on to the second one, but the second one has, let's go, is everyone finished with the second one? I'm sorry. The third one has a little bit complication.
At first I saw this.
Who's finished the second one already? just a couple of more minutes. You could start on the third one.